Here we are looking at another example for hypothesis testing, and this one says a sample of 40 sales receipts from a grocery store has X bar of $137. So that's the sample average. We took a sample of 40 sales receipts, and the average shopping amount is $137. And the standard deviation of the population is given as $30.20. Use these values to test whether or not the mean of sales at the grocery store are different from 150. So what this problem says is that, hey, we're trying to figure out if the average sales at the grocery store is equal to 150 or not. And that's our hypothesis. To prove that or to disprove that, what we did is we collected a sample of 40 sales receipts, and it turned out the average sample average is $137. Well, that is different from 150, but is it small enough to reject that hypothesis or no? It's not small enough to reject that hypothesis. So what we need to do is to start formulating our hypothesis test and start recognizing what are the given information here. Well, this is n, this is our sample size, this is X bar. Sigma, or standard deviation of the population, is given to us. And then this 150 is essentially our hypothesized value. This is our mu naught. And what this question is asking us is the grocery store, mean sales at the grocery stores are different from 150. When it says are different from 150, that means we don't care if it's more than or less than. Different. That means not equal to. And the alpha is also given. Identify the null and alternative hypothesis. So the null hypothesis is always has the equal sign. So we're hypothesizing whether mu is equal to 150. And for the null alternative hypothesis, we're trying to see if his mu is not equal to 150. Identify the test stat and critical region, and then we conclude. Well, we know that test stat z score is equal to X bar minus mu naught over sigma divided by square root of n. Looks like our X bar is $137 minus 150, which is our hypothesized value, over 30.2 square root of 40. If you do the math here, you would get negative 2.722. That is our test statistic. Now, we would have to find the critical region here. The critical region comes from the choice of alpha. So, z of alpha over 2 will be z of 0.005. Negative z of alpha over 2 would be negative z of 0.005. Well, we need to read these values from the table here. For I would have to look for 0.005, and 0.005 is here, right? And that is associated with negative 2.57. So that means this is 2.57, this is negative 2.57. So right here, we know what our conclusion is. We know our test stat, we know the critical region. Let's put that in graphical terms. So basically, looks like the critical regions are negative 2.57 and positive 2.57, and our test statistic is here, negative 2.722. Well, that means we are in the critical region. So what we say is, since negative 2.722 is less than negative 2.57, which is the critical value, we reject the null hypothesis. So what we say here is that we reject this, saying that the average sales at this grocery store is not equal to 150. So we reject that. Essentially, we're accepting the alternative hypothesis. Bad.